What we're going to have a look at today is some things about complementary angles, supplementary angles, vertically opposite angles, and what we call angles at a point. So let's have a look at what complementary angles are. These are two angles that share the same vertex, the same corner, and sum to 90 degrees. Remember, sum means to add. So two angles, same vertex, and add to 90 degrees. So here we've got a right angle, a 90-degree angle, and I'm going to cut that up into two angles. So I've got this angle and this angle. Together, if I turn to there and stop, and then turn, keep turning and face there, altogether I've faced or turned 90 degrees. So I can use that fact to help us find any missing angles. So if I know that this part of the angle is 60 degrees, and I know the whole thing is 90 degrees, then these two angles must sum to or add to 90 degrees. So they're complementary angles. So the two angles added together are 90 degrees. My reason, which I haven't got written there, is complementary angles. And then the angle subtracts 60 from both sides, and that it equals 30 degrees. So what are supplementary angles? Well, these are two angles that again share the same vertex or corner, and this time, instead of adding to 90 degrees, they add to 180 degrees. So let's have a look. There's a straight angle, adds up to 180 degrees. Let's cut it into two angles. They've got the same vertex, this part and this part. Altogether, we would turn 180 degrees. If I know that this is 130, then these two angles must add up to 180 degrees. And again, I haven't got the reason actually written there, so I'll put that in now. But they are supplementary angles. And then I can subtract 130 from both sides, and then I find that theta is 50 degrees. So we've had a look at complementary, adds to 90, supplementary adds to 180. Now quite often people get confused between the two. So complementary comes first alphabetically, and 90 comes before 180. So complementary 90, supplementary 180. And hopefully that makes it a little bit easier to remember. So let's move on to what we call vertically opposite angles. Vertically opposite angles occur when two straight lines meet, and we'll find that there's actually four angles created. So there's one straight line, there's another straight line. They're not parallel, so they must cross when they're not parallel. And we notice that we've got 1, 2, 3, 4 particular angles there. Well, let's have a look at what happens. So let's say we measured that, and that amount of turning was 140 degrees. Well, because this is a straight line, we might be able to find something in particular about it. So what we'll do is I'll actually cover up this line a bit just to make it a bit easier to see. There's our straight line. We've got two angles here. Two angles must add together to give this straight line, which is 180 degrees. So 140 plus 40 gives me that 180 degrees. So our missing angle there is 40 degrees. Okay, so we now know what two angles are. So let's have a look at this angle here and see if we can work out this missing angle just in here. So what I'm going to do is, again, I'm going to move up part of that, cover some of it. We have a straight line there. In a straight line, the angles add up to 180 because they are supplementary. So if that's 40, 40 plus 140 gives us that supplementary angle there. So we have now 40 and 140 gives 180 degrees. And we could do a similar thing and actually work out if that's 140 and we have a straight line there, they have to add up to 180 round here. So that missing angle there must be 40 degrees. And what you should notice is something special about when two straight lines cross. You see these opposite angles? they end up working out to be the same, and same with these two opposite angles. Yes, I know these ones aren't actually vertically opposite, and in fact if I rotate that around, they could neither of the angles be vertically opposite, but we just call them vertically opposite angles there. So when two straight lines cross, the opposite angles are equal. So, as we just said, opposite angles are equal, and we call them vertically opposite angles. So, these vertically opposite angles are actually equal. So let's go on and have a look at what we call angles at a point. Well, if we have several angles, in fact it could be as small as two angles, and they share the same vertex, and together they complete a full revolution. That means they go all the way around. Well, they're known as angles at a point. So let's have a look at a diagram. So here we go. We've got 1, 2, 3, 4 angles in this example. If I was to start here and I turned clockwise, then you'll notice that these 4 angles would come back to where we started from, make an angle of revolution, 360 degrees. So we call these 4 angles angles at a point, and there's our point there that they meet, our vertex. So let's label our angles now. So we've got this angle, 1, 2, 3, 4 angles. Some of them could be the same size, but it looks like they're all different. So when we add all 4 of those together, they should make an angle of revolution, which means they should add up to 360 degrees. So if I was to do this particular question, I'd write down my angles, say that they're equal to 360 degrees, and my reason is angles at a point. So there's some more basics. So we've looked at complementary, supplementary, we've looked at vertically opposite angles, and now angles at a point. So they'll be useful for when we do some things with triangles and quadrilaterals later on. Okay?